All right, let's jump right in. Today, we're going to follow a thread that starts with a single molecule in our atmosphere and ends with the laws that build our cities. We're going to connect the dots between global climate science and, really, on-the-ground survival.
So, let me ask you something. What in the world connects a smoke-belching power plant, a big international treaty signed in Kyoto, and a devastating typhoon hitting the Philippines? It sounds kind of like a riddle, right? Well, stick with me because by the end of this, you'll see exactly how they're all links in the very same chain.
Here's our roadmap for today. We're going to start with the really big picture science, the planet's heat trap. Then, we'll zoom in on the specific ingredients causing all the warming. After that, we'll check out the world's rule book for how we've tried to handle it. From there, we'll land in a specific country right on the front line. And finally, we'll connect all those dots, from the science right down to survival.
Okay, first things first. Before we can even get into the weeds on law or policy, we absolutely have to get our heads around the basic science. So let's start with how our planet's heat trap actually works. So let's start with a really simple idea, the greenhouse effect. Now, this process itself isn't a bad thing at all. In fact, it's what makes life on Earth possible. You can think of certain gases in our atmosphere as this perfect planetary blanket, trapping just enough of the sun's heat to keep us cozy. The problem isn't the blanket itself. It's that we've been making that blanket thicker and thicker.
And here's what that thicker blanket looks like in the real world. I mean, these aren't just computer models or predictions anymore. These are things we can measure right now, all over the globe. We're seeing it in rising average temperatures. Our oceans are literally soaking up more heat. Sea levels are climbing, and our planet's ice, from glaciers to the Arctic, is visibly shrinking.
So what exactly is making this blanket thicker? Let's take a look at the actual warming ingredients, because it turns out not all greenhouse gases are created equal, not by a long shot.
This table really breaks down the main players. You've got carbon dioxide, CO2, which is the big one. It's the largest contributor, and it just hangs around in the atmosphere for centuries. Think of it like salt in a recipe. You need a lot of it to really notice the effect. But then you have methane, CH4. Methane is more like a ghost pepper. A little bit has a huge immediate punch of heat, but it fades faster, breaking down in about 12 years. And then you've got nitrous oxide and these F gases, which are both super potent and they stick around for a very, very long time. So, faced with all this science, what has the world actually tried to do about it? Well, that brings us to the Global Rulebook, this whole collection of international agreements designed to tackle the challenge.
You can really see a clear evolution in how the world has approached this. It all kicked off in 1992 with the UNFCCC, which basically just set a big broad goal. Then in '97, the Kyoto Protocol got more specific with legally binding targets. But, and this is a big but, only for developed countries. By 2015, with the Paris Agreement, the whole game changed. The world realized this needed everybody on board, so it shifted to a framework where every single country sets its own targets.
Now, underneath all of these agreements is this one, core principle. And yeah, it's got a mouthful of a name, common but differentiated responsibilities. But the idea is actually pretty simple. It just means that while climate change is a common problem for everyone, we have differentiated or different levels of responsibility for fixing it. And that responsibility is based on who emitted the most historically and who has the money to do something about it now. And this quote just lays it out in plain English. It's not just about wealthy countries cutting their own emissions. This principle says that the nations who have historically pumped the most carbon into the atmosphere also have a bigger duty to help other countries, with money and technology, to fight climate change. Okay, so we've been way up here at 30,000 feet talking about international law. Let's bring this all the way down to the ground. Let's focus our attention on one single nation that's living on the front lines of this every single day, the Philippines. For the Philippines, this isn't some abstract problem for the future. It's a clear and present danger. We're talking about a country made of over 7,000 islands. It's just incredibly vulnerable to stronger typhoons supercharged by warmer oceans, to sea level rise that literally eats away at their coastlines, into just devastating coastal flooding. So how do they fight back? Well, the country has built its own legal toolkit. And I like to think of these two key laws as partners. First, you've got the Climate Change Act. This is the strategist. It's the big picture plan that forces climate thinking into every single piece of government policy. Then you have the People's Survival Fund. This is the emergency fund. It's the practical money pot that goes directly to local towns and villages for projects that help them adapt and, survive. But as you can imagine, having great laws on the books is one thing. Making them actually work is a whole different ballgame. The path from writing a policy to actually protecting a village is just full of hurdles.
The Philippines faces these huge challenges, like getting all the different government agencies to work together, just finding enough money for these big projects, and simply keeping track of what's working and what's not. And on the ground, enforcing the rules can be really tough, especially when you're trying to balance environmental protection with the person's need to make a living, right now.
And all of that brings us right here to our final section. It's time to tie all these different threads together. Let's trace that entire causal chain we talked about at the very beginning, all the way from the science to sheer survival.
And this is it. This is the whole journey laid out, step by step. It all starts with human activity, burning fossil fuels, farming, industry. That activity releases greenhouse gases. That makes the atmospheric blanket thicker, which causes global warming. That warming then leads to real, tangible impacts, like those super typhoons in the Philippines. And finally, responding to that reality, we create policies, the laws designed to either break that chain or, at the very least, help us survive the consequences.
So what's the big takeaway from all of this? What's the one thing to remember? It's that you can't solve a problem this big from just one direction. It doesn't work. You absolutely need action that's coordinated across every single level, from the big international agreements that set the goals, down to the national laws that create the tools, all the way to the local projects that actually end up saving lives.
Which leaves us with one final and pretty challenging question. If a global treaty like the Paris Agreement sets the goal, and a national law like the People's Survival Fund provides the tools and the money, who is ultimately responsible for actually building the seawall that protects a coastal village? It shows us that the chain of responsibility is just as complex and just as important as the chain of cause and effect.